Hey, Alan, it's nice to see you again. For those of you that haven't sat in on one of our joint sessions, I'm Andrew Nelson. I'm a principal architect for Insight CDCT. And Alan, I'll let you introduce yourself.
Yes, and my name's Alan Clingerman. I'm Chief Technology Strategist for Power Edge and Workloads for the North American channel at Dell Technologies. And thanks for having me back on again, Andy.
Thank you. So this is an extension of a conversation that we've had in a couple other venues. We've been talking a little bit about data center technology and compute options in the past. This specific talk is around some of the trends that we see in AI and edge computing in that AI and IoT space. And it's a hot topic for us at Insight. I know it is for you as well at Dell. We're seeing the market kind of stratify or tier in some fashion into what we like to call a micro and a macro edge. The micro edge is the traditional IoT footprint that I think both of us have seen for a while. It's a small device, single CPU, a little bit of memory, kind of desktop, laptop class. And that's how a lot of our customers initially did IoT. It's how we were doing a lot of IoT designs, really small, low cost, low horsepower, just enough technology to aggregate and pull back the data, maybe do a little processing at the edge. That's what we're calling the micro edge at Insight. We're also seeing a macro edge, which we'll dive into both of these topics. I'm kind of teeing it up for you, Alan. But the macro edge is the more interesting one in our industry, is that's generally has a video component, video or audio or a larger data source or more horsepower in processing. And that footprint looks a lot different. It's got beefy networking. It's sometimes multi-processor servers or multiple servers, and frequently we see accelerators. And you and I have talked about this in a couple other sessions, Alan, but that accelerator technology, whether it's an FPGA, a GPU, a DPU, all of those are really interesting. And the reason I bring it up to you is you coming from the Dell compute side of the house, both of those swim lanes, if you will, are very interesting for different reasons. Maybe you want to talk about some of the challenges in that footprint and what you're seeing on the Dell side.
So Andy, just so I'm clear, like clarification around like when you think about it, because I like where you went. I think the big challenge is that we're seeing with our customers, right, is that executive leader or enterprise architect that's trying to figure out how to take something and put it into production. Like there's been lots of experiments, and I like where you said micro and macro edge. It's exactly it. Everybody's trying to figure out, how do I take maybe those smaller science projects that I might have had and bring it to scale? Because I might have done one thing at the edge, but then we start seeing all these, these interconnection points between the data for you to make a real-time action decision, right? And that's the way we see it, is really the next wave of AI is enterprise and industrial edge. And it's funny you say micro, macro, terms are the same thing. We're saying near edge, far edge, same exact concepts here, right? And it's all about where AI is doing something and automating a process at the point of action. And this is also that area where I see many organizations struggle of really thinking about IT and OT meeting, where some organizations don't even have operational technology people, right? And they started to look at sensors and HVAC and other areas that might meet the facilities team, but they don't have an OT team for innovation to go drive things. And if I'm a manufacturer in the robotics field and in retail and cameras and other things, and being able to look at it differently, right, than just how they're using the technology today. And we're doing a lot of things in this space, right? Certainly in the edge, I'll kind of call this out, and this might have been also what you teed up there, Andy, is when I think about it, there's lots of things going on in this category in the marketplace, and lots of different motions you might want to talk to the viewers about of what you're seeing, right, from a much broader perspective than just Dell Technologies. But we're building a whole business unit on it. We know this is the next big bet. So you might have heard that from Michael of Edge Core Cloud. We are creating a whole edge business unit. So starting right now with telco, retail, and manufacturing, but you can imagine, just start thinking about what this means for all these devices. And I think what you just said of like breaking down in those three discrete areas is going to be very important moving forward. And having an enterprise architect or a leader that can direct his teams from a technology perspective of what they should be looking at for innovation is important.
Yeah, and the code isn't very different. What I find fascinating about this is that micro, macro, edge, a lot of times I'm using a lot of the same containerized solutions, a lot of the same software, but the challenges are very different. And you and I have talked about this offline, is that we're seeing a bunch of industry, your industry peers, exit the micro edge part of that industry, getting out of it, ending products that were specifically designed for them. I guess what I mean by that, for if the viewers haven't seen it, a lot of our vendor partners had, and Dell does too, has hardened boxes that are sealed, fanless. You know, even though they look like a desktop or a laptop on the inside, the outside of them looks more like a car amplifier in a traditional car. They're meant for hostile
Yep.
solutions, because at the micro edge, we may be sticking this on a boat, or we may be sticking this on a shed out in the middle of nowhere. And that micro edge is very interesting in that concept. The challenges there are your remote management and OT challenges. I have a electric utility SCADA background, so you're poking at PTSD for me. But you can't do that with commodity hardware that doesn't have a little bit of secret sauce. And so that's where things like your DRAC intelligence and things like that are interesting. So that's the micro edge and some of those challenges. The flip side is what you and I've talked about before, is how do I do GPUs and accelerators efficiently and get all of that management and OT? And that's a part of the industry that everybody is leaning into. But I don't know that you can do one without the other. We've got a lot of IT deploy or IoT deployments that have a little bit of both. And I need video and I need analytics, but I might just need simple door sensors, and I might need simple thermostats and on-off kind of devices, and I don't need GPU. And so we're going to see a blended architecture in a lot of these IoT deployments where I need 2 of these and 3 of these and these kind of tiers. And so that was why I kind of brought up the question. I like the fact that, you know, I'm not trying to steal your thunder, but Dell is definitely pivoting into both of those markets from an IoT perspective, right? I mean, that's something you and I talked about.
Absolutely, and I like what you said there, because that's exactly right. In fact, you know, you kind of woke me up a little bit on the TinyML conversation.
Well, thanks for that segue. That's the third one we haven't mentioned yet, and that's the curveball that got thrown at me a bit ago. Is there's another kind of opposite pivot that's going on in the market for this TinyML, which is all of this stuff we're talking about, but slimmed down to not even fit on a Raspberry Pi. You know, for those that you haven't seen it, or Raspberry Pi. Smaller than that. It's putting it onto an Arduino chip, or embedding it into a camera, or embedding it into a PLC, or into a sensor. And the interesting thing there is there's not a huge hardware play there. Actually, it's kind of an anti-hardware play. But we're seeing the software vendors go down market. So like TensorFlow has a TinyML light version of TensorFlow that can play there. It's very underdeveloped and very work in progress. But just as much as our industry is pivoting to the right to do the GPU, DPU, FPGA accelerator goodness, this is the opposite. And what I found fascinating about it is it solves a use case that, as enterprise, I mean, you and I deal with the enterprise pretty heavily. It's not an enterprise use case. So it's a sensor that might be on a glacier in Greenland, monitoring glacier flow. The TinyML has a use case of needing low latency, super low power, super low compute, but being able to make decisions on site. And I may not have good connectivity. It might be heavily intermittent connectivity. And that's a very interesting IoT use case we're seeing bubble up. The example that I gave on one of these previous talks was like the packs that they put on the back of whales and animals to track them. Like, what if I can do a little bit of AI, ML on the back of the sensor while the whale is underwater and not have to wait for it to come aboard? But I don't know that Dell's going to have a great play in that TinyML space, but it's fascinating to see how this
it all interconnects, though, like in the project, right? How do you make this stuff real? Because I was even talking to our Octos office after we spoke, and I did some research to understand how we were even using it internally. Like, for example, like sensors in our manufacturing floor actually use ML to do certain things at a robotics level that are very repetitive in nature, right? To train it how to do something very quickly and right there local to the arm, right? So they kind of said, I like what their commentary was, is like very small sample sets, right? So very fixed function. You kind of described that, where it's very low power. And they typically will follow into a model going into something else requiring a deeper data set with GPUs and DPUs that also live at the edge. So those robotic arms then send that sensor data back, right? So they're taking those actions at that specific station, right, to build something, but then they're sending that information back to get a bigger view of what's happening across the plant floor for efficiency. And a larger train model with GPUs and DPUs in the compute, right within the manufacturing floor. So it was just kind of interesting. I had one of the one I thought was interesting. If anybody had visited any of the theme parks, and if you've been to Universal at all, and you've seen Harry Potter, they have a little station where you can wave the wand. That's actually a tiny ML sensor
Wow.
that actually senses how the end user is doing it and uses IoT to trigger something else to happen, right? So
yeah, why send that data back anywhere else if you can process it right there?
all I'm trying to do is spit water at the participant, right? Or flip a sign to interact with the member. So I thought it was great, interesting use cases of tiny ML that also then can tie into either not tie into or tie into a larger framework. And I think
and what you're talking about is this whole AI journey is
yes.
probably all of what we're talking about in some fashion hierarchically, and it's non-trivial. There isn't a recipe for application X, Y, and Z to do that. So that's why these talks for me are so fun, is to kind of exchange ideas, and you get visibility into the building blocks and the infrastructure that Dell is coming up with, and I'm trying to navigate that building block and infrastructure to help customers map this. So no, I appreciate this dialogue, and I think that's about all the time we had today, was to talk about this, but it was kind of a little bit of a teaser, and if anybody's more interested in this, Alan and I love talking about this kind of stuff.
Thanks, Andy.
Thanks, Alan. I appreciate the time.